I'm Olivia and I'm going to introduce you to my research into the conditions that maximise trace metal outgassing fluxes from arc volcanoes. Now, arc volcanoes emit huge plumes that are comprised of volatiles like water and CO2, but also volatile metals such as lead, copper and bismuth, and many of which tend to speciate with chlorine. Now, these gases derive from an exolved magmatic volatile phase, an MVP, in the crust, and are particularly saline and therefore rich in chlorine speciating metals like those that we see in the plume. We know from extensive research that metal-rich saline MVPs are an essential component for ore formation, and so we ask how the metal concentrations and fluxes of these MVPs are generated. Now, to generate metal-rich MVPs requires metal partitioning and volatile exsolution, and since both the plume and MVP are rich in metals that partition as chloride complexes, magmatic chlorine is expected to be important in MVP metal enrichment, but also magmatic water, which actually facilitates the exsolution of the MVP reservoir itself. And so the outstanding questions remaining are then, to what extent does water and chlorine content mediate the maximum metal concentrations and fluxes of MVPs? To address these questions, we modelled crustal MVP development through isobaric crystallization and decompression using 4 hypothetical arc magmatic systems and 3 theoretical metals. The major headlines that emerged were that magmatic water plays a fundamental role in determining the maximum fluxes of both chlorine speciating and non-chlorine speciating metals in MVPs. Additionally, the pressure at which these magmas were stored during fractionation or prior to decompression had a major influence on the final flux of metals. So in the isobaric case, water-poor magmas stored in the deepest reservoirs generated the most metal concentrated signatures, but it was the water-rich and shallow systems yielding the greatest metal flux. In the decompression case, maximum metal fluxes were dependent on the starting volatile content of magmas, with chlorine speciating metals maximised in deep water-rich systems, whereas fluxes of non-chlorine speciating metals achieved in the deepest and water-poor systems.